Hello, this is Neha Daga from Shahid Rajguru College of Applied Sciences for Women, University of Delhi. Today we are going to perform an experiment on Newton's ring. Aim of the experiment is to determine the wavelength of sodium light used using Newton's ring apparatus. Apparatus required: a sodium vapor lamp, a holder consisting of a plano-convex lens over a glass plate, and also with this reflector. This reflector is used to direct the light coming out from the sodium vapor lamp to the microscope and a travelling microscope. It is fitted with two screws. This screw is used to move it in the upward and downward direction, and this is to move it in the forward or a backward direction. This microscope also consists of two scales. This one is the main scale and this one is the circular scale.
Isaac Newton in 1717 first observed an interference pattern formed by the reflection of light between a spherical surface and an adjacent flat surface. A beam of monochromatic light emitted from the source S and moving towards the lens L, and then it is reflected from the lens L to a sheet of glass G. Let the ray now strikes the upper surface of the air film nearly along the normal. The ray is partly refracted in the air film and also partly reflected at the lower surface of the film. The reflected rays, which are produced at the upper and lower surface of the film, are coherent and interfere constructively or destructively. The light which is reflected upwards is seen through the microscope M, which is focused on the glass plate.
Procedure: turn on the sodium vapor lamp. View the dark and bright rings through this microscope like this. If the dark and bright rings are not formed or visible correctly, adjust the microscope through these screws to view them correctly.
It is observed that the series of dark and light rings are seen, with each of them centered at O. These concentric rings are known as Newton's rings. By counting the central spot as 0, move the microscope to the left side using the microscope's screw, counting the dark rings. When the vertical cross wire reach tangential to the second ring, note the main scale reading and the circular scale coincidence. A microscope showing main scale reading and circular scale readings. Final reading of any ring is equals to the main scale reading plus circular scale reading into least count. Now move the microscope and mark the vertical cross wire coincide with 4th, 6th and so on rings, and note down the readings of main scale and circular scale for all the above rings as done before. Then move the microscope towards the right side of the central spot and mark the vertical cross wire coincide with 2nd, 4th, 6th and so on rings, and note down the readings of main scale and circular scale for all the above rings as done for the left side. Make the observation table as shown here. Use the formula to find the radius of curvature of the convex lens. R equals to L square over 6h plus h by 2, where
L is the distance between the two legs of the spherometer and h is the height or the thickness of the lens at the center. To find the wavelength of sodium lamp used, lambda is equals to the square of the diameter of n plus mth ring minus the square of the diameter of nth ring over 4 into radius into m, where m is the number of rings. Another way to calculate the wavelength of sodium lamp is by graphical method, where lambda is equals to tan phi upon 4r. The square of the diameter of the nth ring versus n graph is shown here, where n is the number of rings. It is observed that a straight line graph is obtained. The slope of the graph, which is equals to the tan phi, equals to AB upon CB. Now lambda can easily be obtained using the formula. Result: compare the value of sodium light obtained in the practical both theoretically and graphically with the actual value of the sodium light and hence obtain a percentage error.
Hope that you have learned from this video, and for more details please refer our manuals and PPTs. Thank you.